The researcher claimed that the average income of the town's residents is at most $60,000. You surveyed 40 residents from the town and found that their average income is $63,500 and the standard deviation is 12,000. Write the hypotheses for the hypothesis test and indicate whether this is a two-tailed or one-tailed test. We do not need to complete the whole process of the hypothesis test. We only need to write the hypothesis and indicate whether this is the left, the right, or the two-tailed test. To write the null hypothesis first, we specify the claim, the initial claim. The initial claim from the researchers is that the average income of the town resident is at most 60,000. So the average income is at most $60,000. And we translate it into symbolic form. Another name for the average is the mean. And the claim is about the population, so we would have to use the parameter mu for the mean. The word at most means less than or equals to. At most meaning it can be anything below it up to that number. So this is mu less than or equal to 60,000, and this is the initial claim. We also need to write the negation of this initial claim. The negation of less than or equal is greater than. Think of it as the opposite. If we're not less than or equals, then we're greater than. And the simple mu is the same, the null value is the same. So we basically rewrite everything except for the inequality. And so there we have is the initial claim in symbolic form and its negation in symbolic form. Between the two expressions, the one that does not have the equal sign would go to the alternative hypothesis. And remember that the null hypothesis is always the statement of indifference. And so we have the alternative hypothesis mu greater than 60,000. Keep in mind that just because the negation is the alternative hypothesis does not mean the null is the original claim. The null is the statement of indifference, so it always have the equal sign, regardless of what inequality we use in the alternative, whether we use greater than, less than, or not equals. The null always have the equal sign. And if we use mu for the alternative, we have to use mu for the null. If we use 60,000 for the alternative hypothesis, we would have to use the same number 60,000 for the null hypothesis. And so there we have it, the hypothesis, both null and the alternative for the hypothesis test. From the alternative hypothesis, we can tell that this is the right tail test only because it is greater than. Since this is the right tail test, we say that this is the one tail test, and that concluded this problem.